Okay, hope we have refreshed and have tried some question.
Okay.
Let's carry on.
Section B not so popular.
Yeah. Section B looks like it's not a popular.
Very rare.
Very
Once
rare.
in a lifetime.
Very rare. Yeah, right. Right. Section B is very rare.
Which means I know that means section B most probably won't come out, but still have to be careful.
It's better to try. You better to prepare everything. You don't know which year they will come out. And of course, last minute revision, then you can concentrate on those that are likely to come out lah. 3 capacitors,
Hard one.
C1, C2, and C3 are labeled 300 microfarad, 6 volt, and a range as shown in the diagram below. Determine the total capacitance between P and Q. Okay, so total capacitance, you replace this one first. Right? Replace it with one capacitor. So this one is in parallel, you just add them up. And after that, in series, you take reciprocal. Right? So replace this one, C1 is still there. C2, C3, replace it with that one there. 300, so this is 600. Right? 300 plus 300 is 600. And you just take the reciprocal since it's in series and calculate out. Determine the maximum potential difference between P and Q that can be safely applied. Okay. How are we going to solve that? Right? Each of them is 6 volt, so you cannot exceed 6 volt. Right? So you have to calculate the charge on 300 microfarad, this one. Q is CV, so it's 300 times 6. Right? If you have put 6 volt here, so you got that. Okay, I use microfarad. PD across 600 is V. I remember when they are in series, the charge store is the same. So you have to calculate for C1 first, because if the charge store in C1, you know, then the charge store in the other C2 and C3 share together, as that resultant one will be the same charge. Then you can calculate the potential across these two. Okay? Because the maximum that can go for C1 is 6 volt. Okay, V. You don't have to change it because you are going to use voltage. You put volt and you get volt out. So it's Q 1800 divided by C. 6 is 600. The 3 volt. So altogether, add them out is 9 volt. Can you calculate for C1 first, knowing that the charge store in this series capacitance is the same. Okay. Any comment?
Okay. No.
Charging and discharging. A parallel plate capacitor of surface area 0.24 meter square has a plate separation of 0.65 cm in free space and potential difference 0.8 kilovolt. Determine the charge store. You can see it's very straightforward. Memory will only. Free space. So you calculate your C first. Put in your value. Epsilon naught. Your A. Meter. So you're okay. Separation. Change it to meter. Change to meter. Use calculator to calculate out. And Q equals CV. This one you have to change it already. to nano, change it 10 to the power minus 10. And then V is 800, calculate out. The charge capacitor in A is then discharged through a circuit connected to a resistor of 10 kilo ohm. Determine the time taken for the charge in the capacitor to decrease to half of its value. Okay, so always when it comes to this type of question, calculate the time constant first. Right? Whatever you don't know, calculate the time constant, then they it's up to them to give you the mark. R is 10, change to SI unit, and C we have already calculated here. Okay, calculate out the time constant and use the formula. Most of the formula are the same, right? Unless it's charging then is different. Right? Instead of I, you just use Q, that's all. Then put in your value. You are told half, right? 0.5. Right? That is a time constant. And calculate out. Okay. Any comment? Actually, you can use microsecond, doesn't matter. Don't need to change it all that to SI unit. You can use this one. And then whatever answer you get will be microsecond also. Yeah. Any comment? If not, let's go to the next part.
Next part.
The charge capacitor in A is then discharged. Okay, this one we have done that already. The current after 2.0 is microsecond. Okay, so the same thing. I naught, know how to find I naught. The EMF of the cell of the initial potential difference divided by R. Right? 800. This one kg to SI unit. R is your 10 kilo ohm. Change it to SI unit, so you get 80 milliampere. And use the formula. Right? This 80. Doesn't matter about unit. You use 80, you get milli, you use milli. 80 and then 2 both are in microseconds, so we are all right. Okay.
Okay.
You can see quite straightforward. Okay. Slightly popular. Okay, but there are some years they don't come out. Okay, but if they come out, they try to cover every topic, every subsection. That you can assure that. Define capacitance. Okay, how do you define it? Yep, how do you define it? These are scoring.
Define capacitance.
Yeah, define capacitance. Yeah. Define capacitance. This should be in your head already.
Capacitance is the product of charge over voltage.
Right? It's a ratio of charge stored on either plate of capacitor to the PD across the plate. Two parallel conducting plate of side 5.5 cm are separated by a gap 1.25 cm to form a parallel plate capacitor. The plates are then connected to a supply of 120 volt. Determine the capacitance of the capacitor. Okay, you just want you to memorize the formula and use the formula. Put in your value. That one there. Square that, change it to meter. Then separation, change it to meter. Calculate out. The charge stored, you can see very straightforward. Just memorize the formula, charge stored Okay. Very straightforward, very easy calculation. Okay, any question to ask? Okay, let's carry on. The parallel plate capacitor is separated by an air space of 18.5 cm and an electric supply of 12 volt is then connected to the capacitor and the charge store. Having problem getting rid of all this, cannot see. Then connected to a capacitor and the charge store in the capacitor is 2.46 microcoulomb. A dielectric with dielectric constant 3.06 is then inserted into the airspace between the plate. Determine the electric field strength between the plate. Right? There is this one is basically electrostatic. They can combine the two topics together. Memorize, put in your value, 12 volt, and then your D. Separation. Where's the separation? Right, that's your separation. Change it to meter. Calculate out. Capacitance of the plate after the dielectric is inserted. Okay, Q naught is Q over V. Right, you told the charge stop. And there's your V. Put in there. Plate microcoulomb. Since you use Q is micro. Then your C is epsilon naught times C naught. 3.46 dielectric constant. That's your original one in vacuum or in air. For that, the increase in electric potential energy stored in the capacitor before and after the dielectric is inserted. Explain the microscopic mechanism for the increase. Right? Should be able to calculate that. Initial, right? Q over 2 C naught. Put in your value, calculate out. Final, Q square over 2C. Right? Charge store is still the same, only the capacitance changes. Charge store is still the same, capacitance changes as well. Use a new value. Okay, calculate out. Right? Subtract. So there is a decrease. Why? Yeah, can I explain? Yep. Can I explain?
Explain what, sir?
Inserting a dielectric causes polarization of the electric. Reduce the net PD across the capacitor and thus decrease the energy. No? Yeah. Can? You can, let's carry on. Okay, you find my answer and the book answer is different, but partly because they combine different significant figure. So it's important to work with 3. Don't work with 3 and 2 combined together, you get different answer. Okay. I can see quite common. They ask you to define. Right? You should know how to define. Describe the mechanism of charging a parallel plate capacitor. Okay. How to describe? Basically, when it connect to the battery, The plate will be zero potential. The terminal will be negative and positive potential. So electron will flow from the battery to the negative plate. Then electron on the positive plate is repelled. Is attracted to the positive terminal of the battery. So positive charge build up on the plate connected to the positive terminal. So the potential will keep on building up as charge accumulate until the PD across the capacitor equals to the EMF of the cell, of the battery or cell. Then the electrons stop flowing. Okay. Don't print out the revision note yet because I'm still changing it. I'm still updating it.
No, I didn't touch it yet.
I just let you use so that you can be prepared as well. Review through. Okay with that? Anything not clear? What is the effect on the capacitance if an insulating material is inserted between the parallel plate capacitor? Explain how the effect happens. Yep, want to try? Yep. Right? When an insulating material is inserted into a capacitor, the capacitance increases. That is important for you to realize, to know that. When the dielectric is inserted into the isolated capacitor, the molecules of the dielectric become polarized, aligning along the electric field strength between the two plates. The dielectric produces an opposing electric field between the plate. The resultant electric field strength decreases, causing the voltage to decrease. So from your formula, C is Q over V. As your V decreases, your C increases. That's all. Yeah, just explaining why the capacitance increases. Okay. Yeah. Okay, let's carry on. It's in the revision note anyway. Parallel plate capacitor, there's an area, is charged by a battery, 6 volt. Separation between the plate is 10 millimeter, and the space between the plate is filled by mica of dielectric 5.4. Determine the capacitance. So very straightforward. Memory work, this formula. That's all. Put in your value, 5.4. This is epsilon naught. That's your area. Right? Change it to meter square. Then your separation. Right? Change it to meter. Okay. Have I done something wrong? NCM. Okay. Then calculate the electric field strength between the plate. In there. They want to calculate, they want to involve two topics. Electric field strength and electrostatic. So they can test you two topics at the same time. And they don't have to come out in electric field, electrostatic. Calculate out. Calculate the energy stored in the capacitor. Half CV square. Put in your value and calculate out. Okay. You can see that it's quite straightforward, most of the question. Okay, we do one last one. You need to put in the effort. If not, you're not going to make it. Right? Last round is your effort, not my effort. You have to memorize it, do the past year question, then you are prepared. You come for tuition, no point. It's a waste. I do, I learn. You don't learn. Describe the effect of inserting a dielectric material between the plates of a parallel plate capacitor, right? Same as what we did just now. Right? When the electric is inserted into the isolate capacitor, the molecules of the electric becomes polarized. Polarized is aligned with the electric field between the two plates. The electric produces an opposing electric field between the plate. So resulting electric field decreases, causing the voltage, same as before. Then explain your C increases. Describe the process of charging a parallel plate capacitor through a resistor with the aid of a suitable diagram. There can draw the diagram. There's a diagram. Right? Resistor, capacitor, there's a battery. Right? Electron flow to the plate. Now when you connect it, there is no potential. So electron from negative potential will flow to zero potential. Right? Electron fall to the plate connected to the negative terminal of the battery. Then electron from the connected to the positive plate will be attracted to the positive terminal. Right? So basically the electron here on the lower plate will repel the electron, and the electron goes to the positive terminal. So the voltage will keep on increasing on the plate until the EMF of the plate equals to the voltage on the plate. Then the charge will stop flowing. Then they say resistor, then you have to try to explain what's the purpose of the resistor. The size of the resistor and capacitor slow down the charging process. Right? If this capacitor bigger, it store more charge, so it take longer time to discharge. R larger, also it take longer time to discharge. Then you can bring out, right? Determines how long the capacitor accumulate to about 2/3 of the final charge. Okay. I use the term 2/3 lah, about 2/3. Okay. Any comment? Two capacitors of 10, 50 are connected in parallel and charged by a 120 volt supply. The switch is closed as shown in the circuit below. S is then open, right? You close it. Right? You want the two of them to be the same potential. Right? Two of them to be charged up also to the same potential also. And then you open the switch. Switch is open, and both capacitors are allowed to discharge through the resistor of resistance 500 kilo ohm. Determine the time taken for the potential difference across both capacitor to decrease to 10 volt. Okay, total capacitance. Okay. Parallel, add them up, 60. Time constant. You can see that you want to cover every part of syllabus, as right now they come to discharging. Right? R convert it to SI unit. This one also convert to SI unit. It's 30 seconds. And know your formula, your voltage. So know how to calculate E. E is your initial voltage, 120. Okay. I take the E down, and 120. Then use your calculator to calculate out 24.5. Okay. Any comment?
No.
Okay, sorry, I cannot see. So I have to remove that first. If both the capacitors are connected in series, calculate the required potential difference across both capacitors for the same energy as stored in a parallel connection. Right? Total capacitance. Part 2, total capacitance for parallel one. Right? Then calculate the energy for parallel. You just use a combined capacitance. Calculate out. Remember to change the SI unit. And after that, in series, right? In series, you can do it your own way. Take reciprocal. As I say, I prefer to multiply and then add them up and calculate the resultant when they are in series. And use the same formula, half CV squared. Right? Energy is the same. Put in the energy, half, right? This one, C V squared. Calculate your V. Okay. Anything not clear?
Okay.
No comment. Everything okay?
Okay.
Okay. If okay, I think we will call it a day. We'll carry on tomorrow. Your
Yes,
next
sir.
quiz. Next quiz is electric current. Okay, we'll stop here. Continue to work if you want to get good results.
I'm just most like still paranoid also, sir.
No need to paranoid. The more you do, the better you
Nervous,
are.
I fail.
It's okay. As long as you give your honest work, you'll try again. Nothing to be frightened about. In life, we have to go through obstacle. We have to face challenges in life. Right? Not every challenges is going to be easy. It's just like a baby or toddler. When you fall down, you have to get up and then learn to walk again. Right? So as long as you give your best, nobody can blame you. Try again. Maybe the course is too tough for you. May want to consider a different course that is less challenging. But as I say, put in the effort. The more you learn, the less
Even
you
if
put
fail
in.
also no mind.
Never mind. You put in the effort. You do your best. Yeah, you do your best. Okay, anything else you want to ask me? Put your effort.